Simplifying rational expressions. How do we simplify rational expressions? Make sure that you are pausing when necessary to take your notes. So a rational expression is the ratio of two polynomials. This means it's a fraction with polynomials in the numerator and in the denominator. Because a rational expression involves division, then the denominator cannot be equal to 0. And so any value that will make the denominator equal to 0, we call that an excluded value. So sometimes there are excluded values in rational expressions because it will have the denominator equal to 0, and in any fraction, we cannot have the denominator equal to 0. So state the excluded values for these rational expressions. Okay, so essentially in this first one, we know that if the denominator equals 0, then that means that m plus 2 can't be 0. So I'm going to subtract 2 from both sides. So m cannot be 2. So my excluded value is 2. Excuse me, negative 2. Here I have x squared minus 9. So x squared minus 9 cannot equal 0. X squared minus 9 factors to x plus 3. X minus 3 is equal to 0. So then zero products property says x plus 3 cannot equal 0, and x minus 3 cannot equal 0. So x is 3 and negative 3 and 3. So my excluded values here are 3 and negative 3. You could have also used the square root property to solve, but you have to make sure that when you use the square root property and you take the square root of both sides, then you make sure you know that it has to be plus or minus 3. So you end up with the same thing there. And then lastly, n squared plus 4n minus 5 can't be equal to 0. And sometimes I write can't be equal to 0. Sometimes I write equal. It doesn't matter. Just we know that these are the excluded values. Okay. So what multiplies to give me negative 5 and add to give me a positive 4. Right. So multiply to give me negative 5. Add to give me a positive 4. That's going to be a 5 and a negative 1. So I have n plus 5, n minus 1 can't be 0. So n plus 5 can't be 0. N minus 1 can't be 0. So n can't be negative 5 and n can't be 1. So our excluded values here are negative 5 and 1. So essentially to find the excluded value, then you want to set the denominator equal to 0, and that will tell you what values have to be excluded. So to simplify rational expressions, you're going to factor the numerator and the denominator. Then you're going to divide each by the greatest common factor. So you're going to cancel like terms that appear in the numerator and denominator, because if they appear in the numerator and the denominator, you can cancel them to give you 1. So here we have 54z to the third over 24yz. So 54 over 24, both of those have in common 6. So 54 divided by 6. Oops, sorry about that. Let's go back real quick. Okay. So 54 divided by 6 is going to be 9. 24 divided by 6 is going to be 4. I can't do anything with the y. And then I have a z to the third and a z. So this 3 will become a 2, and this z will cancel out. So in the numerator, I have z squared. Because remember, this is really z times z times z. So one of these z's will cancel with this one and leave me with 2. So This is just like simplifying simplifying when you're looking at exponents. All right. So next, now we have 3x minus 9 over x squared minus 5x plus 6. So in the numerator, we can factor out a 3. So we're going to have 3 times x minus 3. In the denominator, we need to know what multiplies to give us 6, adds to give us -5. 3 and 2 give us 6. If they're both negative, that will give us -5. So that's going to be x minus 3, x minus 2. And then from here, I have x minus 3 in the numerator and in the denominator. Those are going to cancel to give us 1. So I'm left with 3 over x minus 2. Next, I have n squared plus 7n plus 12. So next, now I want to simplify the numerator. So 1 second. So what multiplies to give me 12? It has to give me 7. And it's going to be 3 and 4. So I have n plus 3 and n plus 4. And then what multiplies to give me -8? But it adds to give me 2. So that's 4 and 2. And the 2 needs to be negative. So that's n plus 4 and n minus 2. So then my n plus 4s are going to cancel to give me 1. And I'm left with n plus 3 over n minus 2. And I can't forget my excluded values. So n cannot be -4 and n cannot be a +2. And I get those by setting these equal to 0 and then solving. And then that's how I get those over there. Okay, so I already have a 5x. We're going to keep the 5x. Then for this one, we have to figure out what multiplies to give us 3 and adds to give us 4. It's going to be 3 and a 1. So then we'll have x plus 3 and x plus 1. And then on the bottom, x minus 6 can stay. And then this is difference of two squares. We know it factors to x plus 3 and x minus 3. So right here at this point, we need to go ahead and state what our excluded values are. So we know that x can't be 6 or plus or minus 3. And then we need to cancel out the things that we can cancel. So x plus 3 and x plus 3 both become 1. So in the numerator, I have 5x times x plus 1. And in the denominator, I have x minus 6 and x minus 3. All right, next. So for what value is, one moment, I can't see my screen. For what value is x squared times x squared minus 5x minus 14 over 4x times x squared plus 6x plus 8 undefined? So when I'm looking to see if something is undefined, then basically that means I need to be finding the excluded values, because if it is undefined, that means you have 0 in the denominator. So I'm going to take 4x times x squared plus 6x plus 8 and set it equal to 0. For this portion, I need to know what multiplies to give me 8 and adds to give me 6. So it's going to be 4 and 2. So I can make 4x times x plus 4 times x plus 2 equals 0. Zero products property says I need to set all of these equal to 0. So 4x equals 0, x plus 4 equals 0, and x plus 2 equals 0. So x is 0, x is -4, and x is -2. So for what value is this function undefined? It's going to be all of these values. So sometimes you can factor out a -1 in the numerator or denominator to help you simplify a rational expression. So here I have 4w squared minus 3wy over times w plus y over 3y minus 4w equals 5y plus w. So let's factor that out. So 4w squared minus 3wy, those have a w in common. So I'm going to put a w on the outside, and then I'm left with 4w minus 3y, and then w plus y. And then on the bottom, I have 3y minus 4w times 5w plus y. So when you look right here, my 3y is positive, my 4w is negative, and it's the opposite here in the numerator. So what I'm going to do is I'm going to keep my numerator, w times 4w minus 3y and w plus y. And then in my denominator, I'm going to factor out a -1. And you can do the numerator or the denominator. It really does not matter. So I'm going to factor out a -1. And then, so then I'm going to have a -3y plus 4w, and then 5w plus y. So now these are the same, just in a different order. So then they will cancel to give me 1. So then in the numerator, I'm left with w times w plus y, and in the denominator, I have -5w plus y. And remember that this could also have the negative up here, or you can also have the negative in the middle. They mean the same thing. So let's look at another one that's similar. So xz minus 4z over z squared times 4 minus x. So in the numerator, I'm going to factor out a z because they have a z in common. So then I have x minus 4 over z squared times 4 minus x. And notice that these are opposites here. So let's go ahead and factor out a negative in the numerator. So negative z will give me a negative x plus 4 over z squared times 4 minus x. And if you can't see, or if this doesn't make sense, what's here, then you can also write negative z times 4 minus x so that they look the same, z squared times 4 minus x. And then these will cancel to give you 1. Negative z over z squared, these will cancel to also give you 1. So then in my numerator, I have -1. In my denominator, I have z. And then we want to go back to the original to get our excluded values. So z squared can't be 0, 4 minus x can't be 0, so z can't be 0. This is negative x can't be -4, so x can't be 4. And that is it. If you have any questions, then let me know. Send me an email, post in Google Classroom, whatever you need. Have a good one.